So in the photochemistry we have another topic, that is oxidations and reductions. Okay, so before going into the oxidations means like with a molecular oxygen, molecular O2. So we know that molecular O2 having three term symbols, 3 sigma, 1 del, 1 sigma. So we know that among these three, so this is the ground state, so this is the highest excited state, and this is the first excited state. So this lifetime is more compared to this. Because of that, the most of the reaction takes place from this term symbol. So I have explained this concept in a 16th group element. You can check that video. Now we'll go directly into the reactions. The first reaction what we have is conversion of alcohols into carbonyl compounds. So this is the first reaction we have, and the mechanism is very important for this. So if we see in the mechanism, so in the mechanism we have three steps. The first step is initiation. So what is the mechanism involved here? First we will irradiate this compound in the presence of O2 as well as sensitizers. So sensitizers means triplet sensitizers. So when we irradiate this compound, it goes to the triplet state. So in the triplet state, we'll see then that I will explain the mechanism. So first we will irradiate this compound with oxygen and triplet sensitizers. Now we have a R2, CHOH, and R1, and here we have a triplet sensitizers. This triplet sensitizers abstract this hydrogen, then it forms a radical here. Okay, now this radical reacts with this molecular oxygen, and now this oxygen goes and attacks to this carbon radical. So now we'll get a compound like this, O radical, and this is R2 and this is R1. Okay, so now this is the initiation step. The second step is the propagation step. So in the propagation step, this compound takes this OH. This compound takes one proton from the starting precursor from here, and this gets converts into, see, this is called hydroperoxides, OH. So this is the propagation step. In the termination step, the removal of water molecule, it leads to form carbonyl compound plus H2O2. Okay, so in this they may ask a question like what is the byproducts in this reaction, oxidation of alcohol with the molecular oxide. The byproduct is H2O2. Okay, this you have to remember. So this is very simple reaction. So means like this is not that important, but whatever I'm going to talk now, those things are very important. This is for only for mechanism purpose, how the reactions are going. Like this is Diels kind of reactions. So here we have diene. This is upon treatment with oxygen in the presence of HNO and triplet sensitizers. So we get a this kind of reaction. Upon reduction, we'll get this dialcoholic compound. Okay, and then we have the alene type reaction, ene type reaction here. This is upon treatment with singlet oxygen, we'll get hydroperoxide, and further upon reduction we'll get a allylic alcohol here. Okay, so the mechanism what involved here, like this is the kind of ene reaction. We have sp2 carbon here. We can miss this may go here, then the radical the double bond forms here, then this is happening. And then we can also see this reaction R2 and R1. This is upon treatment with molecular oxygen, we'll get a oxidine kind of compound. And we know upon this one reduction, we'll get a upon ring opening, we can say upon ring opening we will get a 2 molecules of aldehydes. So these reactions are important. When we have this 1,4-diene like this is upon treatment with water, O2. So only this 1 and 4 carbons involved in the reaction, not this one. Okay, like we can see, we can take like this comes here, this goes here, and this goes here. So we can write this product like this also we can write. And then we have this this compound. This is upon treatment with oxygen, like this bond goes here, this comes here, and this goes here. So we'll get this compound. And then we have this system. C9H17, and here methyl group and alcohol. So this also upon treatment with oxygen, here 1,4 carbons involved in the reaction, and it forms a like this kind of product. And then we have this substituted naphthalene. So here we have like this can also react, or this can also react, but the mainly what you need to remember is that, so in this kind of reaction only dienes involves in the reaction, not this one. Okay, only this one involves, and this reaction is a reversible reaction. So why it's a reversible? So this is a reversible reaction because, see, this is not aromatic compound, but this is aromatic compound. So because of that reason, this is a reversible reaction. Similarly, in case of so these are the some examples we have for photo oxidations. And then we also have oxidative coupling reactions. So what will happens for oxidative coupling reaction? Just coupling takes place. So we have a this cis stilbene. So if we treat this one with H nu, so what product we will get? We'll get a trans stilbene. And upon exposing this one to I2 vapor, the oxidative coupling takes place. Oxidative coupling means like the cyclization takes place. Means there is a new bond formation between these two benzene rings, and we'll get a like this kind of system. This kind of system. So these are the called photo oxidation reactions. So these are the some examples we have for photo oxidations, oxidative coupling reactions. And also one important reaction about phenols. When we are talking about phenols, when we expose this one to photochemical light, then there will be abstraction of this hydrogen takes place. It will be a O radical now. And in the resonance structures, it can also exist like this. This bonds goes here and the free radical come here. This is the first one. The second one is this can go here and the free radical comes here. So now the reactions will take place from these two states. Okay, and from here also we will get totally 3 products in the oxidation reactions. When the oxidation means the reaction takes place from this stage, I mean we are taking 2 molecules of phenol. The what product here we will get is a biphenolic system which is having a this kind of compound. Here hydrogen, and here's one more hydrogen like this. And from this system we'll get a product like this, and after that upon reduction you will get this kind of compound. This is OH, this is OH. In order to get aromaticity, this compound will convert into like this. And when you're talking this about this compound, here we'll get so in this case this radical and another molecule of same radical. Okay, another molecule of same compound. See here the radical is here and the double bond comes, the carbonyl compound comes here. So oxidative coupling means we can say that like sorry, this cannot be oxidative coupling, this is photocoupling. Sorry, photocoupling. What is the coupling reaction? Like in photocoupling means like two same molecules gets couples each other. Okay, and when it is getting coupled and there is a formation of a bonds like this, and in order to get aromaticity, this compound gets converts into like this OH and OH, and from here we have this compound, and this free radical, another molecule free radical comes and it takes just like this, and there is a double bonds are like this, and finally it converts into OH. So why I'm this is not means they may not ask this question, but they can ask in such a way that how many products you will get in this reaction. So we will get 3 products. So one product is having 2 para positions, one product is having 2 ortho positions, and one product is having 1 ortho and 1 para position. So these are about the photo oxidations, oxidative coupling and photocoupling. And next video I will make on reduction reactions. And I think with this I will finish all photochemistry. I have made many videos on photochemistry. So if you have any doubts, you can write in the comment box, and if you like my video, you can subscribe to my channel, and also please forward to your friends. Thank you.